So today, the student will be able to use the properties of logs in order to solve the given equations for x. We have solved log equations for a couple days now. We are still doing that. All of the ones you've seen so far worked out kind of pretty, and sometimes they just don't. So you need to know what to do if that happens. So let's start with something that we do know how to do. So if I have 3 to the x power equals 27 to the power of 3x minus 16, you know that the exponential property, the exponential function's properties, say that if I can get the same base, then I can solve the exponents. So I'm going to take 27 and turn it into a base of 3, because I know 27 is really 3 cubed. So I have 3 cubed now to the 3x minus 16 power equals 3 to the x power. Okay, now your properties of exponents say that if you have an exponent raised to another exponent, you can keep the base and multiply the exponent. So it's 9x minus 48. So distribute the 3. Now that I have the same base, I can get rid of the bases and solve for the exponents. Because if the bases are the same, the exponents must be the same because that's a property of equality. So I'm going to now solve for x. So minus 9x minus 9x. So negative 8x equals negative 48. Divide by negative 8. And we know that x equals 6. Okay, now in the second example, I have a base of 2.4 and a base of 9. There is no way to make 2.4 and 9 into the same base. There's no base that could be created from those. So if they cannot create the same base, then the only way to solve the problem is to use a log. So what we're going to do is we're going to take the log of both sides. So if I take the log, and we're going to use the natural, or not the natural log, but we're going to use just the log base 10. So we're not going to write the 10. It's just understood. So that's the most common log. So we have log of 2.4 to the 3x plus 1 power equals log of 9. So you can do that because what you do to one side, you have to do the other side. And so it's still equality. You're still equal. You didn't change anything. So because I took the log of both sides. Now, the properties of logs say that if I have an exponent, I can pull that exponent down in the front. So really I have 3x plus 1 times log of 2.4 equals log of 9. Okay, now my goal is to solve for x. So I need to isolate the x. So I'm going to divide by log of 2.4. So that I can try to get the x by itself. So now I have 3x plus 1 equals. Now here you need to be very, 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 very careful. We're going to round to 3 decimal places. Decimal places. Which is the 1,000th place. Okay, it's very important that you start understanding how to round into problems like this. If you end up in the AP Calculus class, and some of you will and some of you won't, but in any math class, you need to be able to round to the specific instructions they give you, or even in some of your science classes. When I take log of 9 divided by log of 2.4, it gives me 2.5097, so on, so on, so on, so on, so on. When you take your calculator, and you need to be using the graphing calculator, so the one that's on your Chromebook, the TI-84, do not delete that. So when you type log of 9 divided by log of 2.4, you're going to put this in parentheses. It's going to open a parentheses to close it twice. Divided by log parentheses 2.4. You want to make sure all that's separated. Then it's going to give you an unending decimal. Don't clear it. Immediately after that, you just type, we know the next step is minus 1. So you just type minus 1, and the calculator will say we're going to take the answer, A-N-S, minus 1. And so then it's going to tell you we have 1.5097, so on, so on, so on, so on. So it's going to hold all of those decimals that you couldn't have written all of them down because there's really some hiding in there that you can't see. Now our next step is you're just going to type divide by 3. And the calculator will write, we want the answer divided by 3. So if you don't type anything else in between, it's going to hold that answer, and you just keep doing the math along with it. So now you know x equals, and now at the final step, now you round to 3 decimal places. So my final answer is 0.503. So a couple of things happened in that problem. I can't get the same bases for my exponents, so I take both sides, I take the log of both sides. Then do not round throughout the problem because it's going to mess up your final answer. And so you hold everything you have, round to 3 decimal places at the end. Okay? All right, example number 3. I have log base 5 of 11 is equal to 2. Is equal to x. So the first thing I'm going to do is there's only a single log. So you know in order to solve logs, if you only have one log and not a log on both sides, you need to change it to exponential form first. So I have 5 to the x power equals 11. Now I have it in exponential form, but I'm stuck with a base of 5 and a base of 11. And there is no way to make those the same base. So I need to take the log of both sides. So log of 5 to the x equals log of 11. Now, another reason you have to do this is your TI-84 calculators, all your scientific calculators can only compute base 10. So the calculator can only compute that most common log of base 10. So the calculator only computes base 10. So you can't type log base 5 of 11 into your calculator. So we changed it to exponential form. That doesn't work. So now we're going to take the log of both sides, a base 10 log. Okay, now I can use the power property and take this x down in front. So I really have x times log of 5 equals log of 11. My goal is to isolate the x, so we need to get rid of the log of 5. So divide by log of 5. So I have x equals, when we type that in the calculator, you get 1.490 is what we end up rounded to 3 decimal places. So I want you to make sure that you type this into your calculator and you understand why this is my final answer. Because I did it before. It really is like a longer decimal than that. So make sure you understand why that's rounded to 3 decimal places, okay? All right, example 4. In example 4, I have log base 3 of x to the 6th power equals 12. There's only a single log. There's only a log on one side. So I'm going to change this to exponential. So I have 3 to the 12 equals x to the 6th. Well, I can't get them to be the same base because I have a base that's unknown. So what I can do is I can take the log of 3 to the 12 equals log of x to the 6th. I can use the power property on both sides. So I have 12. That was 12. So I have 12 times log of 3 equals 6 times log of x. Now, I can't divide my logs because that's where the x is. So to isolate the x, I'm going to divide by 6. If I can get rid of the 6, then I only have log of x, and so now I'm closer. So divide by 6. So now I have 2 times log of 3. Okay, now we can use the power rule again. So this 2 can again become a power, because then I have log of 3 squared equals log of x. Now I have a log on both sides that will cancel. So 9 equals x. Ta-da! All right, the next one, I have 2 logs, but they're on the same side. So I'm going to use my properties to write this as a single log. So remember, when you have subtraction between two of the logs, when you write them as a single log, that subtraction becomes division. So it's really log of x plus 3 divided by 9 equals 3. I only have a single log, so I need to change it into exponential form. So you need to remember this is really a base 10. So I have 10 cubed equals x plus 3 over 9. Okay, but I can't get those to be the same bases at all. I have a base of 10 and a base of whatever, but I don't need to because my x is not in the exponent. So I'm going to take 10 cubed. 10 cubed is 1,000 equals x plus 3 divided by 9. If I multiply by 9, then that will cancel the denominator. So I have 9,000 equals x plus 3 minus the 3. And you have 8,997 equals x. All right, and that's it for your notes today.